Hello everyone. This is Mr. 13 Things coming at you, demonstrating one more homebrew quiz, if you would, or methodology on the Khan Academy exercise framework. Once again, this is unsanctioned and such that it's open source, and so as long as you'll have to look at what that means. You have a number of exercises, up to 150 right now, working their way up through mathematics. Of course, there are many of you that aren't and can't wait in this new changing education world for all of the exercise to be developed on a top-down model. So we're looking at how you can go about using the basic framework and once again running off of a local install here, or perhaps just off of a USB drive. And that probably would be the first place for you to go. What you probably lose with the USB is the monitoring or the data, the metrics, which is one of the great things about Khan Academy, that you can see where you or students might be struggling, where communication things break down. Let's take this with a grain of salt. This is being built upon, this model here is being built on I would say the first Khan Academy module that has a manipulative in it, and that manipulative you'll see in the middle of the screen here is a protractor. I haven't taken the time to change that to some other symbol, but I will do that in the next video. This is basically a proof of concept, and I'm going to take you now through how this would work. Alright, so you would load up to the correct module, and you see it flashes a bunch of text there, and this is what the problem says. Drag the protractor to the best definition of moment or torque. And what you see in front of you there, just take a picture of that. You see the definitions, those of you who know, of angular momentum, which is the IW, moment of inertia, times the angular velocity. The second one is, in fact, the answer, r cross f, the radial vector about the point of rotation as a cross product with the force vector. The next one is angular kinetic energy. The next one is work going across the top. So F dot D is work. MV is momentum. R cross V is angular velocity. 1/2 mv squared is kinetic energy. And R cross R, if those are position vectors, is basically the definition of the normal. So what I'm going to show you here is, in this case, we're just selecting from 8 out of 8. So we're going to select the same 8 and shuffle them each time. You could actually be bringing in other distractors, and we'll demonstrate that in a later video. I'm just going to hit the recharge or the rewind here, if you would. Go through here, and you see they're going to come back, and this time R cross F is over here, number 4. And so the next time, and I'm going to go around here about 3 or 4 times. See, each time it's shuffling those pictures and putting them in a different spot. Now, because of the way I've coded this, basically I know I have not fixed the coding for it, the correct answer to follow this thing around, so I'm going to keep hitting. You can realize that this is going through and using the shuffle function, a very useful one. I'll try it 1 or 2 more times, and then we'll just go with the wrong answer, if you would. Alright, so this is going through each time, and you can think about how this could be used for definitions and the like. Alright, that's what it looks like. In fact, now let's look at what the code is that generated that. First off, this field as it's laid out here is around 840 across by 400 up and down, so that breaks up pretty nicely into 200 squares, or even better than that, perhaps for some higher order might be that would be 8 times 4, 32 potential options. And you can think about breaking this up into all kinds of a different grid, if you would. I'll point some of you out to Mathematica. Look at its image function capability, what it can do, and I can just envision the puzzle bit coming from this. All right, that said, I've got all of these are basically PNG files that are drafted on a transparent background. Great thing about PNG. So that way I can kind of identify here R cross V in one file and one in another file, and they don't kind of overlap each other. Now when I go to I'd like a hint, and again this is not correct, you see that it's going to go ahead and go over the top of some of those and give me down to here, neither of which is correct. So that's sense here. I'd like another hint. Finally, in the end, I said the answer is number 4, which I've lost, so that's not so great anyway. So that's what that looks like. I'll try it one more time. You can see it. Hopefully I'm pulling it down into here. I'm going to do a recharge. You see it comes around, and what the goal here is basically to allow someone to grab, not necessarily give the number here, but grab it, do a query on where this thing is placed. Obviously these are, you know, pretty straightforward image maps if you keep it to a grade of 4, 8, 16, whatever you want to do, so I could grab it to any one of these things. Here, of course, is that great manipulative, so you might, I don't know what you do with that, but take away that functionality and just leave it so it has the ability to pull, move around, taking from its center point, which I think is there. I'd like a hint one more time, comes across the top and the top. All right, now let's look at what the code looks like. Now, I'm going to go right here. Once you've got some basic things set up in terms of functions to bring in these images, this is what that code looks like. It's listing all of the potential pictures you have, index numbers from each of them. It is then shuffling that, and the function I don't have built is that you could keep track of, in this case it's t1.png, which is the correct. Better names, of course, would make more sense. And so this one here would actually have to go through and figure out where in index mix 0 resides. It's a pointer problem. You're probably going to develop maybe about 10 types of these if you're really going to be trying to keep the mix there with the students, and at the same time keep track of what they're doing, trying, what they're missing, what they're not getting. This one I will lay out for the 390 facts that I believe that our students should have based on my experience in a 2-year engineering classroom. Most of those facts, many of those facts would go back all the way to around 5th grade when we're learning how to divide by fractions, decimals, and the like. All right, so that said, here's what the code looks like. Inside, again, very pro forma. In fact, you can just go ahead and be changing different things up. What you're doing is you are using a function to bring in a picture, and then grabbing 0 through 7, which is 8 things. But of course, this is the shuffled mix, so it's going to shuffle it differently each time. That is the value of the way this engine works. It's allowing you some real ability to not present the same problem the same way. This stuff here is actually the overlay for the numbers, and this is just playing around, and then this brings in that protractor right there. And inside that protractor is an ability to then discover, based on a response to some sort of click, where is that protractor. So you could get the answer from that. I go down to the hints here, and then you see that the hints are just bringing in a different picture, this one not being transparent. I will finally point you out to where you would draft. One of the best things I found for doing is to stick with Khan Academy as much as you can. Sal Khan uses Smooth Draw 3.0, gives you a great ability to write out things on a transparent background in PNG files. That's the value. Anyway, that's what we've got. I'll end it up here and show you one more time what it looks like. Again, now that you've seen it, we're going to recharge. Get that recharge. And of course, we know the answer is R cross F, so the answer should be 1. It's not going to be correct here, so apologize for that. Thanks for listening. Get out to Khan Academy. Get out to www.github.com/Khan and look around and think about the power that you as a classroom or a parent have for molding some of these quizzes in addition to working with all the great ones that are out there at Khan Academy. Thanks for listening.